Okay, we're now going to look at curve sketching within differentiation. Now, to sketch a curve, what we're looking for then is to find the stationary points and their nature. So for that one, that's a max, and that one is a min. But we're also looking for where we cut the x-axis and where we cut the y-axis. So what's true on the y-axis? X is equal to 0. So we'd make x equal to 0 to get what would be called the y-intercept, where we cut the y-axis. What's true on the x-axis? That's the roots. That is y is always equal to 0. And we would find the stationary points in their nature through our skills that we've already gained with the stationary point tutorial and lesson. Okay, so let's try one of these to get going. Sketch the curve y equals x cubed minus 3x squared. Okay, so let's first of all find the y-intercept, so where the thing cuts the y-axis. Now, what's always true in the y-axis is that x is equal to 0. So let's note that down. So let's sub that in. Y equals 0 cubed minus 3 lots of 0 squared, which is 0. So we can see clearly then that the point in which we cross the y-axis is 0, 0. Let's now try the x-axis. And what's always true on the x-axis? Well, this time y is always equal to 0. And let's note that. So x cubed minus 3x squared is equal to 0. Common factor of x bracket, or rather common factor of x squared bracket x minus 3 is equal to 0. So we've got x squared equals 0, or x minus 3 is equal to 0, which is x equals 0 or x equals 3. So the point at which we cross the y-axis then was 2, 0, 0 and 3, 0. Okay, so the points at which we cross both axes then can be clearly listed as 0, 0 and 3, 0. We're now going to find the stationary points. Okay, so the stationary points, remember, are positions of 0 gradient, so let's differentiate the function, and that will be 3x squared minus 6x is equal to 0. So for dy by dx is equal to 0, that's looking at stationary points, so a statement to that effect. Let's take out a common factor of 3x, bracket x minus 2 is equal to 0, which is 3x equals 0 or x minus 2 is equal to 0. X then is equal to 0 or x is equal to 2. So that's the x coordinates at the stationary points. Now I want to find the y coordinate, so I sub the x coordinates into the original function for y. So sub x equals 0 into y. So that'll be y equals 0 cubed minus 3 lots of 0 squared. That'll give me 0, so we can see then that stationary point 1 is the origin, 0, 0. Let's see if it's stationary point 2, which is getting an x coordinate of 2. So let's sub x equals 2 into y. That'll be y equals 2 cubed minus 3 lots of 2 squared. 2 cubed is 8, 2 squared is 4, times it by 3 is 12, 8 take away 12, and that's minus 4. Stationary point 2 then is 2 minus 4. Okay, let's now investigate the nature of the stationary points. So that'll be setting up a nature table. Okay, so I've got a stationary point at 0 and a stationary point at 2, and I'm looking to investigate the neighbouring values. Okay, so a neighbouring value is 0. Beforehand could be minus 1, between 0 and 2 could be 1, and after 2 could be 3. So let's investigate first of all at x equals minus 1, so dy by dx will be equal to 3 bracket minus 1 squared minus 6 bracket minus 1. So minus 1 squared is 1, times that by 3 is 3. And then minus 6 times minus 1 will be plus 6. 3 plus 6 is 9, that's a positive result. Remember that I'll have 0 gradient at 0 and 0 gradient at 2. So positive gradient, the slope's going along, then it's going up rather than going along, and further going along at 2. So let's now investigate at x equals 1. Okay, so that will be 3 lots of 1 squared minus 6 lots of 1. That's 3 take away 6, which is negative 3, which is a negative result. Slope's going down. Let's now investigate at x equals 3. dy by dx will be equal to 3 lots of 3 squared minus 6 lots of 3. 3 squared is 9 times 3 is 27, minus 6 3s are 18, which is 9, and a positive result. And it's going up so that we can see that that is a max followed by a min. So we've got a max turning point at 0, 0, and a min turning point at 2, minus 4. We can now sketch the curve. Okay, so we know that we cut at the origin 0, 0 and cut at 3, 0, so that's where we cut the axis. We've got a turning point at 0, 0 and a turning point at 2, minus 4. Now in terms of measuring out our diagram, it doesn't need to be completely exact, but 3 should be further away than 2, and minus 4 should be further away than 3. So we cut the axis at 0, 0 and 3, 0. 0, 0 is also a turning point, which is a max, so I can put a max shape through that. And I know that I've got a minimum turning point at 2, minus 4, so that might be along to here and into about there. And I'll put that in. That is a min. And then it's just being careful and sketching the thing out, and it will look something like that. Okay, let's try another example. We're going to sketch the curve of y equals x minus 2 bracket x plus 3 all squared. Okay, first thing, let's check the y-axis by making x equal to 0. That'll be y equals 0 minus 2 bracket 0 plus 3 all squared. Okay, so 0 minus 2 is minus 2, multiplied by 0 plus 3 is 3, 3 squared is 9, so 9 times minus 2 is minus 18. Okay, so the point then is 0 minus 18. Let's now investigate the x-axis. So for the x-axis, I'm going to make y equal to 0. So that'll be x minus 2 bracket x plus 3 all squared is equal to 0. Okay, the thing's already factorised, ideally. So x minus 2 bracket x plus 3 bracket x plus 3 is equal to 0. X minus 2 equals 0, or x plus 3 is equal to 0. So that's x equals 2, or x equals minus 3. So that's now 2, 0 and minus 3, 0. Okay, so I can collect together my points at which across the axis, which is 0 minus 18, 2, 0 and minus 3, 0. Okay, and my next move then is to find the stationary points. So let's differentiate the function. Okay, so the function is given by y equals x minus 2 bracket x plus 3 all squared. So I'll need to prepare to differentiate first of all. So that's x minus 2 bracket x squared plus 6x plus 9, and that's just expanded out that squared bracket. Okay, so that's x bracket x squared plus 6x plus 9 minus 2 bracket x squared plus 6x plus 9. Let's expand the thing out, so that'll be x cubed plus 6x squared plus 9x minus 2x squared minus 12x minus 18. I can then collect together terms. So that'll be x cubed, 6x squared minus 2x squared is 4x squared. And 9x take away 12x is minus 3x. And finally I've got minus 18. Okay, now I'm going to differentiate the function. So that'll be dy by dx equals 3x squared plus 8x minus 3, and make the thing equal to 0. So dy by dx is equal to 0 for stationary points. Okay, I've looked for a highest common factor, but can't find one, so it's going to be straight to 3 times minus 3 is minus 9. Two numbers that multiply give minus 9, add together to give 8, that's 9 and minus 1. Okay, so that'll be 3x plus 9 bracket 3x minus 1. The second bracket cannot be factorised further, but I can take out a common factor of 3 here, so that will be x plus 3. X plus 3 is equal to 0, 3x minus 1 is equal to 0. X equals minus 3, 3x is equal to 1, x equals 1/3. So my stationary points occur at x equals 1/3 and x equals minus 3. Okay, let's now find the y coordinates at the stationary points. So I'm going to sub, first of all, x equals minus 3 into the function for y. So that's y equals minus 3 cubed plus 4 lots of minus 3 squared, minus 3 lots of minus 3, minus 18. So minus 3 cubed is minus 27, minus 3 squared is 9 times that before is 36. Minus 3 times minus 3 is plus 9, and then I've got a minus 18. Okay, so minus 27 plus 9 is minus 18, minus 18, minus 18 is minus 36, plus 36 is equal to 0. Okay, so stationary point 1 then is at minus 3, 0. Let's investigate the position of stationary point 2. So I'm going to sub x equals 1/3 into y. So that will be y equals 1/3 cubed plus 4 lots rather of 1/3 squared minus 3 lots of 1/3 minus 18. Okay, so throwing all that in the calculator and taking your time, and you should get minus 500 over 27. Okay, so stationary point 2 then is at 1/3 minus 527. Okay, next move is to find the nature of the stationary points. So for that purpose, let's set up a nature table. So stationary points occurred at minus 3 and 1/3. Okay, so a neighbouring value before minus 3 might be minus 4, a neighbouring value between minus 3 and 1/3 might be 0, and after 1/3 might be 1. And we're now going to put these into the differentiated function. So remember that the differentiated function was given by 3x squared plus 8x minus 3. So 3 lots of minus 4 squared plus 8 lots of 4, take away 3. Minus 4 squared is 16 times that by 3 is 48. 8 fours are 32, take away 3. And that will give me 77, which is a positive result. I'll have 0 gradient here and 0 gradient here. So the slope's going up before minus 3. Let's now investigate what's happening at x equals 0. So dy by dx this time is going to be 3 lots of 0 squared plus 8 lots of 0 minus 3, which will give me a result of minus 3. So that's negative, and the curve's going down. Let's now investigate what's happening at 1. Okay, so that will be dy by dx equals 3 lots of 1 squared plus 8 lots of 1 minus 3. So that's 3 plus 8 minus 3, which will give me 8, which is a positive result, and the function's going up. So it's a max followed by a min. So it's a max turning point at minus 3, 0, and a min turning point at 1/3 minus 500 over 27. Okay, I can now set this up in a diagram. So 0 minus 18 may be around here. I'm now cutting also at 2, 0, which might be about there, minus 3, 0, which may be there. Okay, so I've got a max at minus 3, 0, a min at 1/3 minus 500 over 27, which is a bigger negative result than minus 18. Okay, and the curve may look something like that.